26.2 Snapshot 5 was just released, and we got a new archetype for the Sulfur Cube. TublePie said, "Have you seen the latest snapshot that added the first mob to interact with redstone? They wonder how that works under the hood." Like, technically we had copper golems, but that doesn't count. These guys, they love to explode. Let's run that back. What just happened? We have a Sulfur Cube in the world, and if you know anything about Minecraft, you know entities like Sulfur Cubes are ticking. We had redstone dust under that Sulfur Cube. When that was powered, the Sulfur Cube started blowing up like it was TNT itself. So the Sulfur Cube has its own tick logic. It attempts to tick fuse, and it attempts to prime when on powered position. Prime when on powered position, that's the main logic of what we want to look at. I'll show you tick fuse real quick. Our fuse, which is an integer beginning at -1, if our fuse is greater than 0, then we start decrementing the fuse. And when it reaches 0, we call it to drop the leash in case the Sulfur Cube was leashed by another entity or by the player. Then we remove the Sulfur Cube, and we create an explosion in the same level and same position as the entity was. Prime when on powered position, make sure that we're only operating on the server or logical side. Then we call it to this dot can explode, see if we can explode, and that is this dot max fuse from archetype is present, which is an optional integer representing the max fuse that a TNT archetype Sulfur Cube can take to explode. We also double check that the Sulfur Cube is alive and that it's not already primed for an explosion. We get the block position of our entity, and then we call it to level.getBestOwn or neighbor signal at the same location of the Sulfur Cube, and we make sure the signal level is not at 0. This comes from the signal getter interface, which is purely about redstone signals. So what happens in this setup where we're powering the block under the Sulfur Cube and we give it TNT? It still explodes. So back in signal getter, we can see this here, get best owner neighbor signal. We see this call to get best neighbor signal, and then we also check if the block state itself that we're looking at is a signal source, and then if it is, we get that signal or return 0. So we're getting the max between these two values here. So that's what the best signal means. Then when we say own or neighbor, if we are a signal source, then we return our own signal. So if this block is a redstone torch, we return 15. Otherwise, we return the best neighbor signal. So for every direction in directions, we can look at this here. This is from directions.values, which is an enum. So this is down, up, north, south, west, and east. So think of the Sulfur Cube as that blue glass in the middle. We're checking every block in the surrounding position around the Sulfur Cube in the world. So in this case, the block below it is being powered. So we begin with a variable of our best signal being set to 0 because we haven't found a signal at the very beginning. Then for every direction around the Sulfur Cube, we get the signal. We call it to this.getSignal, which gets the signal. We get the incoming signal from that direction. If that's greater than or equal to 15 or the max value, then we just go ahead and return 15. Otherwise, if that's greater than our best signal, then we set our best signal to that and then go to the next iteration or next direction through that. Then finally, we return the best signal that we found. So this .get signal here, we can see this method. So we get the block state that we're looking at. Then we call it the state.get signal with this level or signal getter, the position and direction. And this is just getting us deeper into the redstone logic in general of how redstone works. So we could follow this logic through and do state.get signal, which calls to get signal on the block itself. That calls to the self-defined method own signal. And if we search for overrides of that, we can find one in button block. So if the button is powered, we return a full signal of 15, otherwise we're returning 0. All of this revolves around server level implementing signal getter. So if we go up here and do Control H, we can look at the hierarchy and we can see signal getter going all the way down to server level here. So at a high level, it's pretty straightforward. The Sulfur Cube just detects redstone signals around it, gets the best signal it finds. But under the hood, with it actually having a fuse and ticking the fuse and then priming, there is a bit of additional logic behind everything. And so prime when on powered position, at the end of this, we do this dot prime time and we set to false or imminent. Imminent here, this is the Boolean describing whether redstone activated the TNT, and we can see this here in the article. When primed by fire, redstone absorbed TNT uses a fuse time of 6 seconds. When primed by an explosion, absorbed TNT uses a randomized fuse time between 0.75 and 3 seconds. So explosions cause them to explode a lot faster. So besides these Sulfur Cubes, we also have geysers now. And if we stop and look at this, there are multiple textures being used here. We have this upper part, we have this middle part, we have this bottom part, and then obviously the yellow one's the noxious gas. So we can scroll down here in the release notes. We see Geyser, Geyser Poof, Geyser Base, and Geyser Plume. So we do have the 4 registered particle types. When you look at the textures, we have Geyser Base, Geyser Plume, Geyser Poof. So we look at these. Geyser particle options is used twice for the regular Geyser and for Geyser Plume here. And those options are exactly the same as well, and those say true for that. So one of the issues is these require water blocks, which is a positive integer. So this is extra data that you need to give if you're trying to use it in the particle command. See, if I try to do particle Geyser, we see no key water blocks in map like. So we have to write it out like this with the curly brackets, and then we're doing water blocks set to 1, and I'm moving the position up 2 so it's not at my feet, it's at my head instead. And now we see a Geyser Plume being launched like that. And we could even change that to be 3 or 4 or however many blocks that we want, and it just goes higher and higher. So these are not all equal. We saw Geyser and Geyser Plume have the same particle options codecs. Geyser Base and Geyser Poof use this codec instead from Geyser Base particle options. This one needs water blocks as well as burst impulse base, which is a float. So let's change this to Geyser underscore Poof, and we get an error here because we're still missing that, right? So what we need is burst impulse base. So I'm going to copy that, and I'm going to set that to 1.0 like that. So now that might have been hard to see that little poof. The geysers themselves are implemented with a block entity, which I thought was a little bit strange at first, but when you see all the logic behind it, it kind of makes a bit more sense. So we have Potent Sulfur block entity, and we have different block entity tickers, which are either server or client side. Some of them are for the nausea effect, some of them are for noxious gas particles or geyser plume particles, or launching entities, or the cooldown state or countdown state. So most people are probably interested in the launch entity ticker, so we'll look at this. We have the find source block, which calls to find noxious gas source block at the level and position of the block entity itself. So we have a floor of magma blocks with sulfur cubes on top of that and some water above that. So let's look at this. The max Y, or max distance away from our sulfur block entity, we do get Y, which gets the Y position of our block, and we add 4 plus 1 to get the area where gas should be spawning above the water. So we have a max distance that we're allowed to check to. We create a new mutable block position. This is so we can pass the same object around. Origin is where our block entity is. So we do origin dot above 2. That's 1, 2. So the first place that we would be able to spawn gas, if there's not more blocks of water above this, we start here. This while statement, we're making sure that we're not hitting that max range yet. In this example, let's say we have 2 more blocks. So we're hitting this. We're checking if this is not fluid water. And since this is water, we skip through this and do pause.move up and check the next position. The while statement makes sure we're not hitting the max yet. We check to see this is not water. Well, this is water, so we move the position up again. This is misaligned for this example, but now we're still below the max. The position was just moved up again. We're still below the max. Now we're checking that the fluid state here is not water. This is not water anymore. This is open air. So we check, is this air? Well, this is air, yes. So we return the position that we're at, which is this current block. So if there is noxious gas spawning, if that's an open block, we only have a gap of 4 water blocks above our potent sulfur, and we continue to do this logic, and we continue with this logic. We count the amount of water blocks by finding the difference between our potent sulfur block entity and the position that we just found where noxious gas is spawning. So say that we had 4 blocks of water in that gap above our potent sulfur, we would multiply that times 5, so we create a bounding box that is 20 blocks tall. When we call to inflate, it expands from the position that we're starting at, pause here being the position of our block entity itself. So our block entity is here, so we need to offset that so it's slightly above our block entity. And then we search for entities that are within the bounding box we just created. We see this effect predicate here, so we only affect entities that are alive and we ignore spectators. We start by getting the velocity of the entity. We ensure that we have line of sight from the potent sulfur block entity to the entity. If they have less than 0.3 delta movement, as in they're not already being flung upward by something else possibly, then we add delta movement to them. And then this statement down here is just playing a sound once per second. This has been Geysers and TNT Sulfur blocks explained. Thank you for watching, and thank you to our channel members.